Assalamualaikum students. Students, in this video, I am going to discuss about the degradation of cholesterol. In my previous video, I have discussed about cholesterol biosynthesis and its regulation. In this video, I am discussing about cholesterol degradation. Cholesterol breakdown leads to synthesis of bile acid, vitamin D, and steroid hormone. Steroid hormones includes cortisol. Another name is glucocorticoid, aldosterone, and another name is mineralocorticoid and sex steroid. They include estrogen, progesterone, and testosterone. अब हम डिटेल से इनके बारे में डिस्कस कर लेते हैं. Bile acid synthesis. Students, cholesterol, it is acted upon by enzyme hydroxylase, and it converts into 7 hydroxy cholesterol. This 7 hydroxy cholesterol, through multiple steps, it converts into cholic acid, and chenodeoxycholic acid. Upon conjugation with glycine and taurine, they are converted into glycocolate, tarocolate, glycocenodeoxycolate, tarocenodeoxycolate. Then upon dehydroxylation, they are converted into deoxycholic acid and lithocholic acid. Okay, students, and this is in this way the synthesis of bile acid takes place. Cholesterol, upon action of hydroxylase enzyme, it converts into 7 hydroxycholesterol. Through multiple steps, this 7 hydroxycholesterol converts into cholic acid, and also it converts into chenodeoxycholic acid. Upon conjugation with glycine and taurine, they are converted into glycocolate, tarocolate, glycogenodeoxycolate, tarocenodeoxycolate, and upon dehydroxylation, they are converted into deoxycholic acid and lithocholic acid. This, okay, students, glycocolate, tarocolate, glycogenodeoxycolate, tarocenodeoxycolate, these are primary bile acid, while deoxycholic acid and lithocholic acid, these are secondary bile acid. These bile acids are very important in the synthesis of bile salts, and bile salt, they are very important in digestion and absorption of lipid. Okay students, next बात कर लेते हैं vitamin D synthesis. Vitamin D synthesis. 7-dehydrocholesterol, it is present on to the epidermis of the skin, and by action of 7-dehydrocholesterol on exposure to sunlight and ultraviolet rays, it is converted into cholecalciferol, which is a vitamin D3. In next reaction, it is converted into by action of 25 hydroxylase enzyme, which is present in liver. It converts into 25 hydroxy cholecalciferol. Then by action of 1 alpha hydroxylase, it is present in kidney. It converts this substrate into product, and its name is 125 dihydroxy cholecalciferol. Another name of this product is calcitriol, and it is the active form of vitamin D3. In this way, the synthesis of vitamin D takes place. 7-dehydrocholesterol, which is present onto the epidermis of skin on exposure to sunlight and ultraviolet rays, it is converted into cholecalciferol. Another name is vitamin D3. By action of 25 hydroxylase enzyme, which is present in liver, it converts into 25 hydroxycholecalciferol. The next reaction, by action of 1 alpha hydroxylase enzyme, which is present in kidney, it converts into 125 dihydroxycholecalciferol. It is also called as calcitriol, and it is the active form of vitamin D3. And that's how vitamin D synthesis takes place. Now let's discuss about steroid hormone synthesis. Students, cholesterol by action of desmolase enzyme, it requires NADPH and oxygen to the 27 carbon containing compound. It converts into pregnenolone, 21 carbon containing compound. In next reaction, by action of 3 beta hydroxy steroid dehydrogenase, it converts into progesterone. In next reaction, by action of 21 alpha hydroxylase enzyme, it converts into 11 deoxycorticosterone. Then by action of 11 beta hydroxylase enzyme, it converts into the corticosterone. By action of aldosterone synthase enzyme, it converts into aldosterone, which is a mineralocorticoid. Okay, students. Now here, by action of 17 alpha hydroxylase, it converts into 17 alpha hydroxy progesterone. Then, by action of 21 alpha hydroxylase, it converts into 11 deoxycortisol. In next reaction, by action of 11 beta hydroxylase, it converts into cortisol, which is a glucocorticoid. Here, by action of 1720 lyase enzyme, it converts into androstenedione. Next reaction, by action of 17 beta hydroxy steroid dehydrogenase enzyme, it converts into testosterone. In next reaction, by action of aromatase enzyme, it converts into the estrogen hormone, 18 carbon containing. In this way, the synthesis of steroid hormone, cortisol, aldosterone, uh, estrogen, progesterone, and testosterone. Cholesterol, by action of desmolase enzyme, it converts into the pregnenolone, and this reaction requires an ADPH and oxygen, 21 carbon containing compound. In next reaction, by action of 3 beta hydroxysteroid dehydrogenase enzyme, it converts into progesterone, which is a 21 carbon containing compound. By action of 21 alpha hydroxylase, it converts into 11 deoxycorticosterone, and by action of 11 beta hydroxylase enzyme, it converts into the corticosterone. In next reaction, by action of aldosterone synthase enzyme, it converts into the aldosterone. Okay, students, which is a mineralocorticoid. That's how aldosterone synthesis takes place. In next reaction, progesterone by action of 17 alpha hydroxylase enzyme, it converts into 17 alpha hydroxyprogesterone, and here is the 21 alpha hydroxylase enzyme, it converts into 11 deoxycortisol, and by action of 11 beta hydroxylase enzyme, it converts into cortisol, which is a glucocorticoid. Here, by action of 1720 lyase enzyme, it converts into the androstenedione, which is a 19 carbon containing compound. By action of 17 beta hydroxysteroid dehydrogenase enzyme, it converts into testosterone, and last reaction, by action of aromatase enzyme, it converts into estrogen, which is 18 carbon atom containing compound. So students, this was all about the degradation of cholesterol, bile acid synthesis, vitamin D synthesis, and steroid hormone biosynthesis, including uh, estrogen, progesterone, testosterone, sex steroid hormone synthesis, and cortisol and uh, aldosterone. Okay, स्टूडेंट्स, बार बार देखिए वीडियो, कहीं समझ नहीं आती तो मुझसे कमेंट सेक्शन में पूछ सकते हैं। थैंक यू।